Hello everyone. Today the video will be looking at equilibrium, part of the C5 unit. So first we need to start with looking at reversible reactions and what they actually are and everything. The explanation is actually pretty clear and based on the name. The whole idea is that it is a reaction that can go both backwards and forwards. And it is represented by this symbol, which I think shows this definition quite clearly, because there are two reactions going on at once, essentially, as shown when you basically just show them as two different arrows. And these reactions can go at the same rate, but how do they actually reach the same rate? Quick break from the whiteboard with two of my brother's toy cars. Basically what happens is that one reaction gets slower while the other gets faster, which means that eventually they start going at the same rate. And this is what equilibrium is, where they're going at the same rate. However, as you may have seen if you were looking closely, one of those cars was a Spider-Man vehicle. So for there to be no change with the Spider-Man thing, no drastic change anyway, then there can't actually be any villains, because otherwise Spider-Man will go off and start trying to do stuff, webs and things. So basically, this system in chemistry is called a closed system, which is a system that has no contact with its surroundings. This means that the system is basically isolated, so it can reach equilibrium by itself because there isn't anything affecting it and stuff. You also have to know about what doesn't change during equilibrium, because there is some stuff that doesn't change. And these are basically just the concentration of the product and the amount of product. It's literally that simple. But why, I hear you cry, if you're actually still paying any attention. Basically, this is because forward reaction and backward reaction are both going at the same rate. It basically just means that they are adding to each other at the same rate, so they stay the same, basically. The more complex bit, which you also need to know about next, are what left and right positions are. Basically, if a position with equilibrium is left, that means that the concentration of reactions is larger than the concentration of products. The way you could think of this is with the little crocodile thing, and that thing which there is more of, the crocodile is facing towards that, and then the arrow is pointing towards that, and it's pointing left. If that makes any sense at all, if that doesn't, then just tell me in the comments and I'll try and explain it better. I can probably explain it better when I'm writing it down, sorry. It's basically the opposite if the position of equilibrium is right. It basically means that the concentration of product is higher than the concentration of reactions. It's the same thing with the crocodile and the arrows pointing right and stuff. But what can actually change the position of equilibrium during a reaction? Smiley face. And there are only three of them, which you have to know about, which are temperature, pressure, and concentration. And this is all due to something called Le Chatelier's principle, which essentially means that if something changes, this is bad. It's essentially like the Sheldon of the science world, which is the actual real science world. And essentially anything that changes, you have to find a way to get around that change, to stop it from happening. So by doing the opposite of what's changed. So let's look at an example with temperature. If, for example, the rate of the exothermic reaction was to increase, so more heat is being given out, then this means that the temperature would generally increase. So this would then mean that the endothermic reaction would then have to increase the rate of it anyway, so as to counter this. Sorry about that thing, it was because I was filming and it was, light and everything. So an example of this is the second stage of the contact process. If you increase the temperature, then the backwards reaction, which is the endothermic reaction, which is like you'd be given in the question, that rate then increases to counter that, so then the temperature is then taken down. So yeah. This then means that the position of equilibrium is to the left, and the way that you can think about that is that the reaction pointing to the left has increased. Let's take a look at pressure now. This is actually easier than temperature. Essentially, the reaction which has the fewest moles in it is favoured, so the rate of that reaction is going to go faster. For example, take the formation of ammonia in the Haber process. As you can see, I'm currently circling the moles. So as you can see on the reactant side, there are 4 moles because there is 1 mole of nitrogen, 3 moles of hydrogen. I appear to have written it wrong. So then on the other side, you then have 2 moles of what should be NH3, which is ammonia. So that means that that reaction is going to be favoured because there are fewer moles on that side. So that reaction is going to go faster. This again means that the position of equilibrium is to the left, purely because the fast reaction is pointing to the left. So thanks for watching this, hope it has helped. I apologise about various mistakes I've made, and the lighting which has steadily been creeping over my board.